Hello everyone, hope all is well today. My name is Janamat. The topic of discussion for today will be the computation of a sample mean and a sample standard deviation with a handheld calculator. So just doing the computations by hand without using a statistical software like R or Minitab and so on. So here we have a numerical random variable. It is the number of deaths caused by tornadoes in the United States. The statistical units are years. So for example, the first value, which is 53, is the number of deaths in the year 1990. These are deaths due to tornadoes in the United States. Okay, and so we'll compute the sample mean of these 10 values. And so the first thing that we'll do is we'll compute a sum where we'll just which will just be the total of all the values. So here we have 53 plus 39 plus 33 and so on right up to 90. And then this will give us 630. And then what we'll do is we'll divide the total by the number of values. So the sample size. In this case, the sample size is 10, so there are 10 values, and so we have 630 divided by 10, which gives us 63. And we'll denote this as x bar, and in reality, this is just the sample mean. Okay, and so on average, there are about 63 deaths due to tornadoes in a year. And then, of course, not all the values are in the center. At 63, and so we'll want to get a sense of how dispersed these values are. And so what we'll do is we'll compute a typical deviation away from the center, which is the standard deviation. Okay, there are a couple of ways to compute the sample standard deviation. I'll first show you how to use a shortcut formula. So the first thing we'll do is we'll compute the sum of squares. And so here we have 53 squared plus 39 squared and so on right up to 90 squared, and then this gives us 50,030. And then what we'll do is we'll compute the sample standard deviation, which we'll denote as S. This will be the square root of the sample variance, which is S squared, and then there's a shortcut formula to compute the sample variance. And so what we'll do is we'll compute the sum of squares. Away from that, we'll take away a square, so it's the sum of all the values which have been squared divided by n, and we take this away from the sums of squares, and then we divide this difference by n minus 1. Okay, so in our case we have the square root of, in the numerator we have 50,030 minus 630 squared, which is divided by 10, and then this difference we divided by 10 minus 1. And then once we take the square root, we end up with 33.895, let's say, if we round a bit. And so sample standard deviation is a description of a typical deviation from the center, which is on the same scale as your random variable. So this is a death. So on average we have about 63 deaths per year, and a standard deviation away from the center or away from the mean is about 33 or 34 deaths per year. Okay. Now this is using a shortcut formula. We can also use the definition of the sample variance to compute the sample standard deviation. And so what I'll do is I'll just erase all of my work and start over again. And in this alternative computation, we'll go back to the definition of the sample variance. Okay, and so the only thing that we'll need to keep is the sample mean, which is 63. Okay, and then what I'll do is I'll create a little table of my values. And so here in your table you would have to put all 10 values, but what I'll do in my description is just put a few. So I have 53, 39, and then you'd have to put all the values in your table right up to the last value, which is 90. And then what we'll do is we'll compute each quantity to the mean. So how far does it deviate away from the center? And so 53 minus the mean of 63, this is minus 10. 39 minus 63 is minus 24, and we continue in this way until we get to 90. So 90 minus 63, this is 27. And then what we'll do is we'll compute these deviations away from the mean square. So how far in squared units is each one of these values from the center? And so minus 10 squared is 100, minus 24 squared is 576, and then so on, right up to 27 squared, which is 729. And then what I do is I compute the total of, or if you want to compute a sum of the squared deviations away from the center. So this is 100 plus 576 and so on, right up to 729, and then we end up with 10,340. Okay, and then I want to know on average, approximately, how far away are from the center. So what we'll do is we'll divide this sum by n minus 1. Okay, so the sample variance, which is s squared, by definition is the sum of the squared deviations away from the center. So for each observation I take away the mean, and then I take this deviation squared. I take the sum of all these squared deviations, and then I divide by n minus 1. And this will give us approximately, on average, how far we are from the center. Okay, so in our case, this will be 10,340. We divide this by 10 minus 1, and then I'll just make some room here. I compute my sample variance, which will be equal to 1,148.889. And then sample standard deviation is simply the square root of the sample variance. So I take the square root of 1,148.889, I end up with 33.895 about. Okay, and so this was a computation of our sample standard deviation by using our definition of the sample variance. Alright, so that's it. So this is how you compute the sample mean and sample variance, or the sample standard deviation for a numerical variable with a handheld calculator.